we are going to start with our second chapter, and our second chapter is about materials and its classification, metals and non-metals. That is our second chapter's heading, materials, metals and non-metals. We are familiar with many type of materials like iron, aluminum, copper, sodium, coal, like that, is it? But when we take this aluminum, iron, like these materials, we feel some difference between when compared this item to another material. For example, when we took iron, we know that it has shining appearance, right? And when we touch it, we feel it's very hard, like that. Aluminum also shiny appearance and it is very hard in nature. But when we took coal, its appearance is somewhat dull appearance, and when we touch it, we can feel that it is not very hard. Another example is also there, sulfur. It's also dull appearance and it is not very hard in nature. Okay. So when compared this iron with coal or sulfur, we feel some difference between them, is it? Based on the difference, mainly the difference in physical property and chemical properties, materials are classified into metals and non-metals. So materials, based upon their physical property and chemical properties, they are classified into metals and non-metals. In this chapter, we are going to study detail about the characteristic property, that means physical characteristic and chemical characteristics of metals and non-metals and its uses. Materials are classified into metals and non-metals based upon their physical and chemical properties. Okay. Materials based upon their physical property and chemical properties, it is classified into metals, and on the other hand they are non-metals. Next we are going to study about the physical properties of metals and non-metals. About the physical property of metal, it is hard in nature. Second one, malleable. Third one, ductile. Fourth one, lustrous. Then good conductors of heat and electricity. And the last one, they are sonorous. On the other hand, it is just opposite to that of the metals, and metals are hard in nature mostly, but non-metals mostly they are soft in nature. Some exceptions are there that I will explain. Okay. Then metals are malleable, but non-metals they are non-malleable. The metals are ductile, whether the non-metals are non-ductile. They are lustrous in nature, the metal, but non-metals they are not lustrous. They have a dull in appearance. Then they are good conductors of heat and electricity, but about the non-metals, they cannot allow the passage of heat and electric current. That means they are poor conductors of heat and electricity. And about the metals, they are sonorous, but non-metals they are not sonorous. These are the physical properties of metals and non-metals. Once more, hard in nature about the metal, but non-metals are soft in nature. Then metals they are malleable, but non-metals are opposite to that, non-malleable. Metals are ductile, non-metals are non-ductile. Metals are lustrous property, but non-metals have dull appearance. Metals they are good conductors of heat and electricity, but non-metals they don't allow to pass heat and electricity. That means they are poor conductors of heat and electricity. Metals are sonorous, but non-metals are not sonorous. Next one is about the properties of metals in detail. As I told you, metals mostly they are hard in nature. For example, iron, aluminum, copper, etc. But some exceptional cases are there. Sodium and potassium. They are metals, but they are very soft in nature. Even we can cut the sodium and potassium with a knife. That's what I told. Most of the metals are hard in nature. And another exceptional case is mercury. It is liquid at room temperature. Hard means it shows the properties of solid state, but mercury is an exceptional case. It is present in liquid form in the room temperature. Second property, it is malleable in nature. Malleability. Okay, malleable means, or malleability property means the property of metals that can be turned into thin sheets. We know that aluminum foils, they are used to wrap food. Then silver foils are there for decorating the sweet items. Okay, malleability means the property of metals that can be turned into thin sheets. Example, aluminum foil. Aluminum is beaten into thin sheets for wrapping the food. Third property of metal, it is ductility. It is the property of metal that can draw it into wires. Okay, the property of metal that can drawn into wires, we can call the property as ductility, and that metal we can call it as ductile. Okay, example, copper wire, aluminum wire. Okay, then next property is sonorous. Sonorous means it produces a ringing sound. The metal that has the ability to produce a ringing sound when strike hard. Okay, sonorous means the metal produces a ringing sound when struck hard. Next one, good conductors of heat and electricity. We know that iron nail, when we touch the hot iron rod, we feel very hot because it has the ability to conduct heat. And copper wire, it has the ability to conduct electricity. That's what metals, they are good conductors of heat and electricity. And the last one, lustrous. We know that gold is a best example for lustrous property of metal. Okay, once more, hard in nature. Most of the metals are hard in nature. Exceptional case are there, sodium and potassium. They are very soft and even we can cut it with a knife. And next one, mercury, it is liquid at room temperature. And malleability, it is the property of metals that can be turned into thin sheets. Example, aluminum foil. Then ductility, the property of metals that can drawn into wires. Copper wire is a good example. Sonorous, the property of the metal that produce a ringing sound when struck hard. Then good conductors of heat and electricity. Example, iron rod, it has the ability to pass heat, and copper wire, it has the ability to pass electric current. The last one, lustrous. Good example, we know gold, silver, like that. Okay. Next is the property of non-metals. Property of metals we studied. Next, properties of non-metals. First one, most of the non-metals are soft in nature, but there also occurs exceptional diamond. Diamond, you know? Yeah, it's hard in nature. That is the main exception in the case of non-metal. Most of the non-metals are soft in nature, but diamond is an exception. Then they are non-malleable. That means we cannot beaten it into thin sheets. Next one, they are non-ductile. We cannot draw it into thin wires. Next property, they are not sonorous. That means non-metals cannot have the ability to produce a ringing sound when struck hard. Then they are poor conductors of heat and electricity. They cannot allow the passage of heat and electric current, and they are dull in appearance. For example, coal and sulfur, we know that they are dull nature, dull in appearance. Once more, most of the non-metals are soft in nature. Exception case is there. Diamond, it is hard in nature. For example, coal and sulfur, they are non-metals. Even we can break it into powdery mass when we tap it with a hammer. Second one, they are non-malleable. Third one, they are non-ductile, not sonorous. poor conductors of heat and electricity, and the last one, they are dull in appearance. These are the properties of non-metals, and some of the examples of non-metals, they are sulfur, carbon, oxygen, phosphorus, so many other examples are also there. Physical properties of metal and non-metal we studied. Next is about the chemical properties of metals and non-metals. First one, chemical property of metal. Okay. We are going to see what happens when metal react with oxygen. First one, reaction of metals with oxygen. When metal react with oxygen, metal oxide are formed. When metal react with oxygen, the product obtained is metal oxide. For example, iron. When iron react with oxygen, the product obtained is iron oxide, that we know. Rusting we studied. Process corrosion we studied. Is it? When we left iron outside, it react with oxygen and water vapor present in the atmosphere. Slowly it get rusted. The process we call it as corrosion. Second one, what happens when metals react with water? For example, sodium metal. It is vigorously react with water. Sodium metal is very reactive in nature and it vigorously react with water. That's what we kept sodium under kerosene. Okay. Once more, when metal react with oxygen, metal oxide is formed, and the metal oxide, it shows basic in nature. Acidic and basic property we studied in the 7th standard, right? So, when metal react with oxygen, metal oxide is formed and it is basic in nature. For example, iron when react with oxygen, iron oxide is formed, and magnesium when react with oxygen, magnesium oxide is formed. Second one, the reaction with water. For example, sodium metal. Sodium metal react then it react vigorously with water. That's what sodium kept in kerosene. Third chemical property of metals. That means the reaction of metal with acid. Acid we know, hydrochloric acid, sulfuric acid, so many acids we know. Okay. When metals react with acid, it produces hydrogen gas and it indicates the presence of a pop sound. Hydrogen gas indicates the presence of a pop sound. Okay. So, when metals react with acid, it produces hydrogen gas by indicating a pop sound. Okay. Next one, reaction with bases. Metals react with bases and produce hydrogen gas. For example, metal when react with sodium hydroxide. Sodium hydroxide is an example for base. It produces hydrogen gas. So, once more about the property of chemical property of metal. First one, metal can react with oxygen. That means metal plus oxygen, it gives metal oxides and they are basic in nature. Second one, reaction with water. For example, sodium metal, it vigorously react with water. That's what we kept sodium in kerosene. Third one, reaction of metal with acid. It produces hydrogen gas that indicate a pop sound. Fourth one, metal react with bases. Example, when metal react with sodium hydroxide, it produces hydrogen gas. These four are the chemical properties of metals. Once more, reaction of metal with oxygen. Second one, reaction of metal with water. Third one, reaction of metal with acid. And the fourth one, reaction of metal with base. Chemical properties of metals we completed. Next one, chemical properties of non-metals. That means the reaction of non-metals. First one, reaction of non-metals with oxygen. Let us see what happens when non-metals react with oxygen. Non-metal when react with oxygen, the product obtained are non-metal oxides and they are acidic in nature. Non-metal when react with oxygen, non-metal oxides are formed and they are acidic in nature. Second one, reaction with water. Generally, non-metals, they do not react with water, though they may be very reactive in oxygen. For example, phosphorus. Phosphorus is a non-metal. When we left it exposed to atmosphere, it will react with atmospheric oxygen. That's what. To prevent the contact of phosphorus and atmospheric oxygen, we stored or we kept phosphorus under water. Third one, reaction with acid. Non-metals generally do not react with acid like the metal. And the last one, reaction with bases. Complex reactions may occur when non-metals react with bases. That means several steps may occur, several reactions may occur when non-metals react with base. Once more, reaction of non-metal with oxygen, non-metal oxides are formed and they are acidic in nature. And reaction with water, generally non-metals do not react with water, though they may be reactive with oxygen. For example, phosphorus. Then third one, reaction with acid. Generally non-metals do not react with acid, but they react with base and there occurs a complex reaction. Our second last topic is displacement reaction. Before going to study about the displacement reaction, you have to by heart the reactivity series, starting with potassium and it ends with gold. The reactivity decreases from potassium to gold. Most reactive metal potassium, then next to potassium it is sodium, next to sodium calcium, then magnesium, then aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver and gold. Gold is a less reactive metal. Okay. Once more, this is the reactivity series and the reactivity decreases from potassium to gold. Potassium starting with most reactive element potassium and it ends with less reactive element gold. Potassium, then sodium, next to sodium calcium, then magnesium, like that it ends with gold. Based upon this reactivity series, we are going to study what is displacement reaction. For example, I gave one equation there. When copper sulfate react with zinc, the product obtained are zinc sulfate and copper. Here occurs a displacement reaction, right? Reactants here are copper sulfate and zinc. When copper sulfate react with zinc, the product obtained are zinc sulfate and copper. What happens here? When we look here in the reactivity series, we can see copper and zinc. Which one is in the highest position? Zinc. Below to the zinc, copper. That means zinc has more reactive than copper. That means zinc, which has a more reaction, it replaces copper and it occurs the position of copper there, and the product became zinc sulfate plus copper, because zinc here is more reactive than copper. That's what zinc replaces copper. Another one more example, copper sulfate plus iron. Just look up the reactivity series. Iron, it holds up the highest position than the copper. That means iron is more reactive than copper and it has the ability to replace the less reactive metal, that means copper. Then the product became iron sulfate and copper. When copper sulfate react with iron, iron replaces copper and become iron sulfate and copper alone. Okay, clear? From this it is understood that displacement reaction means a more reactive metal replaces a less reactive metal. A more reactive metal has the ability to replace a less reactive metal, but a less reactive metal, it cannot displace a more reactive metal. The last topic from this chapter is about the use of metals and non-metals. First we are going to study about the use of metals. Metals are used for making machinery, automobiles, aeroplanes, trains, then satellites, cooking utensils, water boilers, etc. Once more, metals are used for making machineries, aeroplanes, trains, satellites, water boilers, cooking utensils, etc. Next, in the case of non-metals, its uses are, it is used for respiration. For example, when we inhale oxygen for respiration, human beings inhale oxygen for respiration. Second use of non-metal, it is used in fertilizer. For example, ammonia, NH3, it is used as a fertilizer for the growth of plants. Then water purification process, example chlorine. We add chlorine tablet to kill the microorganisms that are present in the water. Then we used non-metal for antiseptic purpose, example iodine, and the last one we use non-metals for crackers, example phosphorus. Once more, uses of non-metals. First one, we use non-metal for respiration, example human beings inhale oxygen for respiration for breathing purposes. Second one, we use non-metal in fertilizer, example ammonia. Third one, water purification process, example chlorine we add to kill the microorganism present in the water. Then we use non-metal for antiseptic purpose, and example for that one is iodine, and the last one used in firecrackers, example phosphorus. Once more, I am going to summarize our second chapter. Starting from the first, materials, they are classified based on their physical and chemical properties. First one, physical properties of metal and non-metal. It's about the hardness nature and softness nature. Malleable, ductile, sonorous, lustrous property in the case of metals and non-lustrous property in the case of non-metals. Then sonorous, then and the last one, conductor of heat and light. Non-metals are poor conductors of heat and light, whereas metals are good conductors of heat and light. Then about the chemical property, that means what happens when metals and non-metals react with oxygen, water, acid and base. Then we studied about the displacement reaction, reactivity series, and the last topic we studied is the use of metal and non-metal. I hope you all understood well. Next I am going to give some activities related to our second chapter. This is your activity and it is there in your textbook, page number 54, question number 6. It is there in your textbook, page number 54, question number 6. You have to give the reasons for the following question. First one, sodium and potassium are stored in kerosene. You have to write the reason. Second one, copper cannot displace zinc from its salt solution. Third one, aluminum foils are used to wrap food items. And the last question, immersion rods for heating liquids are made up of metallic substance. You have to read the text carefully and try to write the answer, reasons for the following questions. Okay, thank you.